The entire system consists of several things. So our new Ethernet system for AI, is this. The Spectrum 4 switch and the Bluefield 3 Smart NIC or DPU. This Bluefield 3 is 400 gigabits per second NIC. It connects directly to the Spectrum 4 switch in combination of four things: the switch, the Bluefield 3, the cablings that connect them together, which are super important, and the software that runs it all together represents the Spectrum 4. This is what it takes to build a high-performance network, and we're going to take this capability to the world's CSPs. The reception has been incredible, and the reason for that is, of course, every CSP, every data center would like to turn every single data center into a generative AI data center. There are some people that they deployed Ethernet throughout their company, and they have a lot of users for that data center. The ability to have the capabilities of InfiniBand and isolating it within their data center is very difficult to do. And so for the very first time, we're bringing the capabilities of high-performance computing into the Ethernet market. And we're going to bring to the Ethernet market several things. First, adaptive routing. Adaptive routing basically says, based on the traffic that is going through your data center, depending on which one of the ports of that switch is over-congested, it will tell Bluefield 3 and it will send it to another port. Bluefield 3 on the other end would reassemble it and present the data to the CPU, present the data to the computer, to the GPU, without any CPU intervention, all completely in RDMA. Number one, adaptive routing. Second, congestion control. Congestion control, it is possible for certain different ports to become heavily congested, in which case the telemetry of the switch, each switch will see how the network is performing and communicate to the senders, please don't send any more data right away because you're congesting the network. That congestion control requires basically an overriding system, which includes software, the switch, working with all of the endpoints to overall manage the congestion or the traffic and the throughput of the data center. Now, it's really important to realize that in a high-performance computing application, every single GPU must finish their job so that the application can move on. In many cases where you do all reductions, you have to wait until the results of every single one. So if one node takes too long, everybody gets held back. This capability is going to increase Ethernet's overall performance dramatically. So Spectrum X, really excited to roll this out. The world's applications, the world's enterprise has yet to enjoy generative AI. So far, we've been working with CSPs. And this CSPs, of course, is going to be able to bring generative AI to many different regions and many different applications and industries. The big journey is still ahead of us. There are so many enterprises in the world, and everybody, because of the multimodality capability that I was mentioning before, every industry can now benefit from generative AI. There's several things that we have to do. Number one, we have to help the industries build custom language models. Not everybody can use the language models that are available in a public service. Some customers need language models that are highly specialized for their particular modality. For example, proteins or chemicals. Each one of these industries have proprietary information. And so how can we help them do that? We have created a service called NVIDIA AI Foundation. It is a cloud service that captures NVIDIA's AI expertise and makes it possible for you to train your own AI models. We will help you develop your own AI models with supervised fine-tuning, with guardrailing, with proprietary knowledge bases, and reinforcement learning human feedback so that this AI model is perfect for your application. We then deploy this model to run on NVIDIA AI Enterprise. This is the operating system that I was talking to you about earlier. This operating system runs on every single cloud. This allows this very simple system with NVIDIA AI Foundation for training large language models and deploying the language model into NVIDIA AI Enterprise, which is available in every single model, every single cloud and on-prem, allows every single enterprise to be able to engage. Now, one of the things that very few people realize is that today, there's only one software stack that is enterprise secure and enterprise grade. That software stack is CPU. And the reason for that is because in order to be enterprise grade, it has to be enterprise secure, it has to be enterprise managed, and enterprise supported across its entire life, across its life cycle. There are so much software in accelerated computing. Over 4,000 software packages is what it takes for people to use accelerated computing today in data processing, in training, in optimization, all the way to inference. So for the very first time, we are taking all of that software and we're going to maintain it and manage it like Red Hat does for Linux. NVIDIA AI Enterprise will do it for all of NVIDIA's libraries. Now, enterprise can finally have an enterprise-grade and enterprise-secure software stack. This is such a big deal. Otherwise, even though the promise of accelerated computing is possible for many researchers and scientists, it's not available for enterprise companies. And so let's take a look at the benefit for them. This is a simple image processing application. If you were to do it on a CPU versus on a GPU running on enterprise, NVIDIA AI Enterprise, you're getting 31.8 images per minute, or basically 24 times the throughput, or you only pay 5% of the cost. This is really quite amazing. This is the benefit of accelerated computing in the cloud. But for many companies, enterprises, it's simply not possible unless you have this stack. NVIDIA AI Enterprise is now fully integrated into AWS, Google Cloud, and Microsoft Azure and Oracle Cloud. And so when you go and deploy your workloads in those clouds and you want software that is enterprise grade, or if you have customers that need enterprise grade software, NVIDIA AI Enterprise is ready for you. It is also integrated into the world's machine learning operations pipeline. As I mentioned before, AI is a different type of workload, and this new type of software has a whole new software industry. And this software industry, 100% of them, we have now connected with NVIDIA AI Enterprise. Now let me talk to you about the next phase of AI, where AI meets a digital twin. Now why does AI need a digital twin? I'm going to explain that in just a second. But first, let me show you what you can do with it. In order for AI to have a digital twin, in order for AI to understand heavy industry, remember, so far, AI has only been used for light industry, information, words, images, music, so on and so forth. If we want to use AI for heavy industry, the $50 trillion of manufacturing, many of you are part of, the trillions of dollars of healthcare, all of the different manufacturing sites, whether you're building chip fabs or battery plants or electric vehicle manufacturing factories, all of these would have to be digitized in order for artificial intelligence to be used to automate, to design, to build, and to automate the future of your business. And so the first thing that we have to do is we have to create the ability for their world to be represented in digital. Okay, so number one is digitalization. Well, how would you use that? So let me give you just a simple example. In the future, you would say to your robot, I would like you to do something, and the robot will understand your words, and it would generate animation. Remember, I said earlier, you can go from text to text. You can go from text to image. You can go from text to music. Why can't you go from text to animation? And so, of course, in the future, robotics will be highly revolutionized by the technology we already have in front of us. However, how does this robot know that the motion that it is generating is grounded in reality? It is grounded in physics. You need a software system that understands the laws of physics. Now, you've actually seen this already with ChatGPT. Whereas AI, NVIDIA AI, would use NVIDIA Omniverse as in a reinforcement learning loop to ground itself, you have seen ChatGPT do this using reinforcement learning human feedback. Using humans' feedback, ChatGPT was able to be developed by grounding it to humans' sensibility and align it with our principles. So reinforcement learning with human feedback is really important. Reinforcement learning for physics feedback is very important. Let me show you, everything that you're about to see is a simulation. Let's roll it, please. Everything was a simulation. Nothing was art. Everything was simulation. Isn't that amazing?